Welcome to our tutorial on SQL views. Today we will show you how to create views and store queries permanently for future use. A view is a virtual table that is defined by a query, providing a filtered or combined perspective of data from underlying tables. It does not store data directly but rather presents a dynamic view based on the current data in the referenced tables. We will show you how you can use views for data analysis. We will use the data of a hypothetical bank named Nexus Bank. Link to the dataset is placed in the comments below. We have a list of all bank accounts with typical banking information. There are around 18,000 bank accounts. Then we have the list of all branches, along with their location and GPS coordinates. And customer information, with their gender and contact details. Finally, we have all columns with their appropriate data types, which will help us build our SQL Server database. So, let's start our tutorial by creating a database in our SQL Server for Nexus Bank. Now, let's create our first table. Just copy the list of columns and their data types from this sheet, and paste it inside a Create Table query. Click on the New Query button to create a new query. Now, use the Create Table query to create the Accounts table. Inside the Create Table query, paste the list of columns with their data types. Close the query and execute it to create the Accounts table. Our table has been created, which you can see inside the Tables folder in our database. Use the same query again to create the Branches table. Copy the list of columns used in Branches table and paste it here, replacing the existing list of columns. Now, execute this query to create the Branches table inside the Nexus Bank database. You can view the newly created table and the columns inside the table as well. Similarly, create the Customers table as well, using the Create Table query. Replace the list of columns with the Customers table columns. Execute the query to create the Customers table as well. And here is our Customer table, with all the columns just as we defined in the Create Table query. We also have the data in CSV files, which we can upload into our SQL Server database tables. We can use the bulk insert query to import all data from CSV file into our SQL Server database table. In the bulk insert query, we will use the name of table where we want to import the data, and the address of CSV file, from where we want to import the data. Then we will tell the query which symbol is used as column separator, which in our case is a comma. If you face this error, do not worry, it happened because the first row contained the headings. Although data has been imported successfully, but still we will correct the query and run it again. Now data entry will start from row number 2, skipping the row with headings. Let's delete the existing data first, to avoid duplication of data. And as you can see, all data was successfully loaded, which is now deleted. Execute the query again. And this time there is no error. Now we can use the select command to see all the data in the Accounts table that we have just imported. Everything seems fine here. All rows and columns have been imported perfectly, without any problems. Unless stated otherwise, null values are allowed by default in a Create Table query. Now, let's import the data from Branches CSV file into the Branches table. All 29 rows have been imported successfully, which we can check using the select command. And finally, using the same bulk insert query, we will import data from the Customers CSV file into the Customers table. We can check the data using the select command. And that is it. We have the entire data available in our SQL Server database, which we can now analyze using views. In our first view, we will combine the Accounts table and the Branches table, and create a complete table with information of branches as well. Right-click on the views, and create a new view. Add both tables to the view design. We cannot add the customer's information into this view, because this is not customer-wise data. There are multiple customers in a single row, as the entire row represents a single account. Connect both tables using the branch code columns. Now, add all columns from the accounts table, and all columns from the branches table, except the branch code column as it is already included from the accounts table. Now, our view is complete. Simply click on the Save button to save the view. And enter a name for your view. Click on the OK button to create the view. Our view has been created, which is now available in the Views folder. This view now contains information from both accounts and the branches table. Let's display the entire content of this view. We can use this view to create more views for further data analysis. We can also create views without designer, using the Create View command in Query Editor, just as we will do to create customer-wise information. Now, we will add SQL query to split the government ID values into rows. The Accounts Complete view is called A, and all government ID values have been split and called C, and then they are combined into one view using cross-apply. Now, execute this query to create a customer-wise view. And here is our view. Let's display the entire data and see how it looks like. We had about 18,000 accounts, but now our data has more than 31,000 rows. We have 30,000 customers, but since some customers have more than one accounts, the number of rows are therefore more than total number of customers. Let's check out an account with more than one customers and see how it is split into customer-wise data. This account has 2 depositors, so now it is divided into 2 rows. Government ID of both customers was in one row, which is now split into 2 rows, and each customer has their own row now. All other information has been duplicated, therefore this table cannot be used for many analysis such as total deposit, because numbers are duplicate. The accounts table also does not contain all customers from the customer table, as the data does not include closed accounts. Using the Accounts Complete view, we can create another view to summarize important data branch-wise. Create a view using Create View command. Select columns related to the branch identities such as branch ID, city, state, etc. Add analytical information such as count of total accounts, total depositors, total balance, average balance, etc. Now, group the data by branch information to display all calculated data branch-wise. Our view has been created. Now let's display the data inside, using the Select command. We have now branch-wise summary of total accounts, total depositors, total balance, and average balance during the year. Now, let's perform some interest rate-wise analysis of deposits accounts. Select the interest rate column, and then calculate total accounts, total depositors, and total balance to the view. Group this information by interest rates. We can run the Select command to preview the data before creating the view. Now we can execute the entire query to create the view. We can use the Select command to display the view we created. Similarly, we can create the year-wise analysis of deposit accounts for yearly comparison. We will use the opening date for year column, and then we will add accounts, depositors, and balance as well. Group the information by year and preview the Select command. Now, execute the entire query to create the view. The view has been created with year-wise comparative information. We can also track the movement of our deposit accounts from one category to another, such as from active to inactive. Let's analyze the movement during the year. Select the status of accounts at the start of the year, then at the end of the period, and take the sum of balance at the end of the period. Group the data by both status fields. Let's execute the select command to see if works. Great, it works fine, and shows which account status has been changed, with showing status at the beginning and end. Now execute the entire query to create the view. Now this view has been stored permanently, which you can display using the select command. Similarly, you can create views to display movement during the month or day as well. Another important analysis which is used to measure the performance is how many new accounts have been opened during a period or after a certain date. So, let's create a view to display new accounts created after the 30th of June 2024. We can simply count the total rows, which represent total accounts. And using the where condition, we can include accounts opened after the 30th of June 2024 only. There are 524 accounts opening after the specified date. We can rather display all information pertaining to these accounts than just the number of accounts. The view has been created. Let's see how it looks like by using the select command. Now we can perform other analysis, such as which branch opened the most accounts during the specified period, or how much was their average balance, etc., which we could not have calculated from just a count of total accounts. Actually, we should not have used the equal sign, which also includes the accounts opened on the last day of June 2024. We can simply edit the view and remove the equal sign. Now the number of accounts have been reduced to 519 from 524. We can also create a view to display tagged accounts only. Tagged accounts are accounts tagged to an employee's ID, on the basis of which a predefined commission is paid to employees, as a reward for deposit mobilization. So we will select all data, where tagged date or tagged employee ID is not null. Now whenever an account is tagged, it will automatically appear here. To perform gender analysis, we need to combine customers-wise data with customers table in a new view. Import the customers table and the customer-wise accounts view into the view designer. Now, select all columns from the customer-wise accounts table. And select all but government ID column from customers table. Now connect both tables using the government ID column from customers table and the split ID column from accounts view. Now save the view by entering an appropriate name. I use this name because it contains the name of view or table on the basis of which this view is created. So in views you would know which view is based on which view. Our complete customers-based data is now available in a view, on the basis of which we can now perform gender-based analysis, and any other analysis involving customers. We can use the select command to display all information from this view. And as you can see, each row represents a customer, and the table also includes customer information in addition to their account details. Now, let's create a new view and perform branch-wise gender analysis. Select branch information from the table. Also select the gender column. Use the Count All to count number of depositors against current gender. Include the sum of balance to display total balance as well. Group this data by branch information to display branch-wise gender-based information. Execute the entire query to create the view. And with this, we end our today's tutorial. Next week, we will use these tables and views to display information in Power BI. Thanks for watching. We hope you liked our tutorial. Don't forget to like, subscribe, and hit the bell icon for more insightful tutorials and updates.